Welcome, my dear students of secondary. Today's lesson is called Limit of a Function at Infinity, and this lesson is given for both sections, art section and scientific section. Let's start. Limit of a function at infinity. The main rule, limit when x tends to infinity of the algebraic expression 1 over x equals 0. Here, the first rule, if the two expressions, the numerator and the denominator, have the same degree, then the limit of the function when x tends to infinity equals a number. For example, limit when x tends to infinity of the algebraic expression 2x minus 5 over 3x plus 8. Here, the numerator degree is first degree. Also, the denominator degree is first degree. Therefore, the limit when x tends to infinity equals a number. How can we get the limit of this algebraic expression? Firstly, you should divide both numerator and denominator by x, which has the greatest power in the denominator. Here I'll divide the numerator by x. I'll divide the numerator by x, also the denominator by x. Therefore, 2x over x equals 2, negative 5 over x. Also, 3x over x equals 3, and 8 over x is written as 8 over x. The rule, limit when x tends to infinity of 1 over x equals 0, then 5 over x equals 0. Also, 8 over x equals 0. Then the limit is a number equals 2 over 3. Another example. Limit when x tends to infinity of the algebraic expression 6x minus 4x power 3 over 2 minus 7x power 3. Here, the degree of the numerator is third degree. Also, the degree of the denominator is third degree. Then, the limit will be equal a number. To find this limit, you should divide it by x, which has the greatest power in the denominator, which is x power 3. Then, 6x over x power 3, negative 4x power 3 over x power 3, and the 2 over x power 3, negative 6x power 3 over x power 3. The result, 6 over x power 2 minus x power 3 will be cancelled by x power 3. Then the remainder equals negative 4. 2 over x power 3 minus 7. X power 3 here will be cancelled with x power 3. And the remainder equals negative 7. 1 over x, when x tends to infinity, equals 0. Then this is 0 also. This is 0. Negative 4 over negative 7. And the limit equals 4 over 7. Another example, limit when x tends to infinity of the algebraic expression 2x minus 5 over 3x squared plus 8. Here, the numerator degree is first degree and the denominator degree is second degree. The second rule, if the numerator degree is less than the denominator degree, then the limit will be equal 0. How can we find the limit of this algebraic fraction function? I'll divide both expressions by x power 2 at x, which has the greatest power in the denominator. 2x over x squared minus 5 over x squared over 3x squared over x squared plus 8 over x squared. Then x will be cancelled with x power 2. The remainder will be 2 over x. Also negative 5 over x squared. X squared here will be cancelled with x squared. The remainder equals 3 and 8 over x power 2. 1 over x equals 0. This is the main rule to find the limit when x tends to infinity. This is 0 minus 0 equals 0. Also 8 over x squared equals 0, and the remainder 3 plus 0 equals 3. 0 over 3, the value of the limit here equals 0. Limit when x tends to infinity of the algebraic expression 2x squared minus 5 over 3x plus 8. Here the numerator is a polynomial, also the denominator is a polynomial. X, which has the greatest power in the denominator, is x. So I'll divide both expressions by x. Limit when x tends to infinity of 2x squared over x minus 5 over x, 3x over x plus 8 over x. X squared divided by x is x. Here the remainder equals 2x. Minus 5 over x over x will be cancelled with x, and the remainder equals 3 plus 8 over x. Any number over x when x tends to infinity equals 0. Then the remainder will be 2x over 3. Here x tends to infinity, then the limit here equals infinity. You can see the previous steps again, and the main rule: if the numerator of big degree and the denominator of a small degree, then the limit will be equals infinity, will be equal infinity. Another example. Limit when x tends to infinity of 5x power negative 3 plus 4x power negative 2 minus 3 over 7x power negative 3 minus 2x power negative 2 plus 8. 5 over, take care, x power negative 3 can be written as 1 over x power 3. 5x power negative 3 can be written as 5 over x power 3. Then 5 over x power 3 plus 4 over x power 2 minus 3 over 7 x power 3 minus 2 over x power 2 plus 8. Here is 7 as written in the problem. Any number over x when x tends to infinity, this fraction will be equal 0. I'll cancel 5 over x3, 4 over x power 2 equals 0, 7 over x power 3 equals 0, 8, 2 over x power 2 equals 0. And the remainder will be negative 3 over 8, and this is the value of the limit. Another problem. Limit when x tends to infinity of 3x plus 9 times 2x plus 7 over x plus 1 multiplied by 5x plus 4. Here, in this problem, both the numerator and the denominator are not polynomial functions. They are written as two brackets. You can find the limit when x tends to infinity without simplifying this expression. How can I find this limit? I'll divide each bracket by x, which has the greatest power. Here, 3x plus 9 limit when x tends to infinity. In the first bracket, 3x plus 9, x, which has the greatest power, is x. Then I'll divide only the terms of this bracket by x. And in the second bracket, 2x plus 7, the greatest x, which has the greatest power, is x. Then 2x over x plus 7 over x. X plus 1, the greatest power of x is x power 1. Then I'll divide it by x power 1. Also, here, the greatest power of x is x power 1. I'll divide it 5x over x plus 4 over x. Then x will be cancelled by x, and the remainder equals 3. 9 over x equals 0. 2x over x, and the remainder equals 2. 7 over x equals 0. Also here, in the denominator, x over x equals 1, and 1 over x equals 0. X will be cancelled with x, and the remainder equals 5, and the 4 over x equals 0. 3 multiplied by 2 equals 6, 1 multiplied by 5 equals 5, and the limit here equals 6 over 5. Another problem. Limit when x tends to infinity of x power 3 minus 4x plus 5 over 2x minus 1 all raised to power 3. Take care, the degree of the denominator is third degree. Also, the degree of the numerator is third degree. The greatest power of x in the denominator is x power 3. Also, the greatest power of x in the numerator is x power 3. I'll divide both expressions. The numerator will be divided by x power 3, and only the bracket 2x minus 1 will be divided by the x, which has the greatest power in this bracket, which is x. Therefore, x power 3 over x power 3 minus 4x over x power 3. Here is x power 3 plus 5 over x power 3 over 2x over x minus 1 over x, all raised to power 3. X power 3 over x power 3 will be equal 1 minus 4x over x power 3 is 4 over x squared plus 5 over x squared over 2x over x equals 2 minus 1 over x equals 0 power 3. Again, 4 over x squared will be cancelled because it equals 0. 5 over x power 3 equals 0. 1 over x equals 0. Then the remainder in the numerator equals 1 and the remainder in the denominator equals 2. 2 power 3, then the limit equals 1 over 8. The last problem, limit when x tends to infinity of the expression 1 over x multiplied by square root of 3 plus 4x squared. Here we can write this problem in the form of limit when x tends to infinity and square root of 3 plus 4x squared over x. Take care. The numerator expression is not a polynomial. Then I'll divide the numerator by x, which has the greatest power of this expression. I'll divide the numerator by x squared. Also, the denominator, I'll divide the denominator by x, which has the greatest power, which is x. Then limit when x tends to infinity of square root 3 over x squared. Take care, I'll divide the numerator by x squared plus 4x squared over x squared over x will be divided by x. Then 3 over x squared equals 0 and x squared will be cancelled by x squared and the remainder here will be equals the square root of 4 over x divided by x equals 1. Then the remainder equals square root of 4, which equals 2. And this is the limit when x tends to infinity. Thank you.